Next up, what I'm going to do is I'm going to take the other half. I like to put onto that a fuse, especially now on the spike systems, because there is no inline fuse. So first things first, this is designed to go through a circuit board. We don't want the end pieces, so first thing I'm going to do, I'm just going to break those off, and then what we'll do is we will solder it directly on. So it's just a quick case of taking those off and screwing it into place. Oops, put a bit more off than that. So we'll pop that on there with a screw, and we'll sort out the second half. Pop that through there. I'm going to screw that in place straight through. Trying to keep it level if I can. So what we're now going to do is we are going to connect this to our other half. Before I do that, the tags that stick out the back where we solder on our wires, they need to be bent around at 90 to allow us to fit that so they don't foul too far at the back when we put the motor on. So easiest way to do this, you're not going to be able to see this, I'm afraid, unfortunately, is just to quickly bend them around out of the way, like so. That's going to go on the end, and it's once again going to be a tight fit. And then we're going to screw these in place, get it level if I can. It's just a case of screwing in our two cap heads as we did before. So once again, I'm going to need two screws, which drop into there, and our screwdriver. This is even more fiddly than the other side, because now there is a little bit of pressure on there. So I'm just going to drop that into there, hopefully tightening by hand. And then we'll screw that in using our hex wrench. As I say, once again, if I had one with the ball end on, it would make this a lot easier. So, those things. So I'm going to roughly screw that in place for now. And then I'll flip this over, do the same on the other side. And that way if I need to adjust it, I can do. Pop that to there. Once again, tighten that in place. Sometimes these can be a little bit fiddly. So I'll just give that a quick wind in a moment. Make sure it sits fairly square. I'm not too worried if it is a little bit on the skew, because that once again adds a little bit of prevailing torque into it, which helps it not come undone in use. So once again, I'm just going to tighten these in place. Not too worried if that spins for now. We'll tighten all that up at the end. I'd say this is a great case in point where if I could attach it directly to the motor, it would save all this fiddling about. So give me a moment and I'll do that. Okay, so best blue Peter traditions is one I've assembled earlier. So what we're going to do now is we're going to start wiring this up. Now what I like to do is, rather than connecting a wire directly from the live side to the live side of the motor, I like to put in a diode. My thoughts on this is that it's because it's a motor, it has electrical noise. So this in effect prevents back EMF going back in and destroying your node board. So diode, I'm going to put in, what it basically does is it acts as a one-way gate. So we have our diode which is sat like so. Let's get it on there. And it has a line this end. So what this is doing, this is allowing current to flow through our device this way, but what it does is this acts as a little gate and stops it from flowing backwards. So this is great, but it does mean that you have to actually fit this, the correct live to the correct live and the ground to the ground, otherwise it just won't work. So if you actually fit one of these motors and it doesn't work, the first thing to check is that you've got the wires the right way around. So what we're going to do, we're going to connect this and we're going to put our diode in somewhere here. So the first thing we're going to need to do is to bend this over. A little bit tricky, so I am going to use a set of pliers if I can find them. So typically I can't find my pliers, so what I'm going to do is I'm going to use a set of these pipe wrenches instead. Now we need to flow from the fuse around this way, so that means we need the gate down this end like so. So first thing I'm going to do, I'm going to take the end, I'm going to bend that at 90, just going to offer that up, see where that comes, and then we'll bend the other end accordingly, which is about there, which is 90 degrees off in that direction, somewhere about there. So we end up with that. It's not super fussy, because obviously this has a little bit of give in it anyway, so it's not a problem. And that we will solder in somewhere like so. So the first thing we're going to need to do is we're going to need to drop some solder onto this end just here. This is a case where, as everybody that does any soldering knows, you need 3 hands. So we'll see how we go, especially as I'm upside down for the camera. So quickly what I'm going to do is I am going to run some solder just in there, and that will allow us to solder our pot on. Okay, so I'm going to take my diode, pop that into there. I'm going to solder that down into the end of that. A little bit more solder on the end of my tip. Hold that about in the right place and basically give it a stab in there and make sure it's well soldered. I'll come back to that in a minute and adjust it. What I want to do is to get the other end in. This is where sometimes you do have to bend it, and I've bent that a little bit too far. That is going to pop into the end somewhere about there, like so. And then I'm going to solder that on the back so it makes a connection. All of this I'm going to test in a moment anyway, so if it doesn't work I can always come back and have a look at resoldering it. Okay, and I'm just going to give that a quick push through. Okay, so there's our diode in place. Probably just going to give this a bit more of a solder. So tricky to see on the camera, but that solder is not great. So I'm going to give it a bit more of a polar solder and make sure that it is well seated. Okay, lovely stuff. So, started to make our connection. We will have in there a fuse. I'll pop that in at the end. That's obviously our weak link, so that if for some reason this motor did stall out, it'll blow the fuse rather than blowing your node board. So what we're going to do now is we are going to wire it up using our wire. So I use black and red rather than ground. We need to run enough off there to allow us to get back to our board. Now I do actually have these measurements down there, but I am going to give it kind of the length of this board just here, which is the length of the playfield. So that should be plenty to fit. So we are going to go that length there and chop that off. And we're going to do the same with the red. So quickly get that kind of the same length. At this point it's not really critical because I will need to trim it at the end. So we will go somewhere near and then we'll do that at the end. Go down there. Okay, so we're going to strip the 2 ends. I'm old school, so what I have here is the old spring top. I'm not one of these fancy strippers that everybody has these days. Does the job, so I'm not making millions of these. I don't really need all that fancy kit. So I'm just going to strip those 2 ends and then I'm going to tin those. Now this is definitely a case where you need 3 hands. We'll see how we go. So I'm just going to tin those before we start. That will allow me a chance at soldering this up using 2 hands rather than 3. So giving that a quick tin and giving that tin also. So we'll carry on with our live side. So what I'm going to do is, once again, I'm going to run some solder in here. Extremely tricky to get into, but I'm sure we'll manage. So we'll give that a bit of solder in there. Then we'll take our live end and we will solder that in place down there in the bottom. There is actually enough clearance in here to allow for that glass fuse. Okay, so that's that end done, and then we're going to do the same with our piece of ground that I've dropped on the floor, which is always useful. So what I'm going to do first of all, I'm going to fully tin this terminal here, and then what I'll do is from there I will pop the wire through. Pretty much that'll be it done. So let's grab a bit more solder. Solder with an L in it, by the way, not solder. Sorry all my American friends, but there's this thing called syllables. Okay, right. Take my piece of wire. I'm going to pop that through there. Just heat it slow, gently. Pop that through. Pretty much that's done. Right. So we're going to neaten our wires up now. We'll pull these out. And they're going to come down to about here. Now what I like to do is put a cable tie just over this piece, and that's basically you're going to hold it in place, so if anybody does tug on it, it'll stop it moving. Apart from that, all I need to do is make the connections the other end, and that's the main body of it done. Then we'll test it and make sure it's working correctly as we suspect it should do. Keep that nice and neat. No real secret to this. Pop it through, don't matter which way. And I'm just going to cable tie it to that cross brace. Try and get them fairly neat if I can. And then we should just basically tighten it up. Chop the end off and we're good to go. Right, so the next thing we need to do is we need to look at the 2 end pieces of wire. Before I start, I'm just going to stretch those out and make sure they are still the same length. So as you can see, one is now a bit longer than the other. Just going to trim them back the same. That just makes it sit a bit better in the Molex connector in a moment. So these connections, the board using one of these 5-way Molex connectors, 156 thou spacing. So what we're going to do, we're going to connect into there. Now I have made a little fixture because trying to hold these is quite tricky. You're trying to hold it, push the wire in, and they kind of flop side to side. So I've made a little fixture. On there it has some lengths and it tells me a little bit of what I'm doing. And so our 5 pin is going to go in the middle just here. It sits that way around. That goes into the slot. So it's telling me the red wire is in this one, black wire is in this one, wires running off down here. So if I just straighten those wires out a little bit. Dead simple. What we're going to do, whoops, that's going to get in the way. Red wire we're going to pop into this one. If you haven't got yourself one of these Molex tools for inserting the pins and for inserting the wires, do, because it makes a really difficult job really easy. So that's basically going to pop onto the top of there, and then I'm going to give it a press in, and that's going to fit it in like so. And the same with the black wire. This is where, if you're not careful, it all gets a little bit tangled. So I'm just going to trace that round as best I can, and then we're going to pop that one into the black side as it says, and then push that one in. Once again, give it a quick one then. That's a done job. So pretty much that's our shaker body and assembled and wired. What I will need to do now is to test it. So first things first, and the bit I always forget, is to actually put in our fuse, and then we will test that using our electronic tester. So 2.5 amp fuse is what we're using. These are, I believe, quick blow ones. Doesn't really matter for what we're doing. That's going to go into there and complete our circuit. So down here I have an electrical tester that I can set to any voltage, and we are going to set it to 12 volts. Whether you can see that or not, we will try and focus on. Can you see that? 12 volts. I'm afraid it's upside down, but that's the way it goes. Right, so what I'm going to do is I am going to connect this up to our Molex connector, and then we're going to check that. The easiest way to do that is to get a header pin, which I will steal off the pot down here. So I'm going to connect that into my header pin that way, and then we are going to run the motor up and check everything works okay. So this is doing two things. This is checking the motor connections, but also what it's doing is it's checking that we have the diode the right way and that the motor is good. Out of the 300 or so motors I've actually had, I've only ever had one that doesn't work. Oops. So it's a case now of checking to see what happens with the pot here. And I'll probably need to turn up the bridge. Oh, that's interesting. Let's blown that up. Okay, so somewhere in here we can turn that up. Okay, so you can hear the motor running. I'm going to focus on that. Oops, this is a bit horrible. But just about see it there. So what it's telling us is that it is running at 12 volts, which it should be, and it's pulling 1.5 amps. So it's within spec, so I know this is good. So we're going to fit our blocks on the end. For the first thing I'm going to do, I'm going to line that up with our... I'll just basically press it on in place. And take a screw, and we are going to Loctite these in place because this is the only thing really holding it on. There's no reason why it should come undone, but it certainly isn't going to come undone if we put a little bit of Loctite on it. Put that on there, and then we are going to screw that down into place. I'll know if I've got it correct because it should go in and the screw should sit almost flush to the top because that's the way I've designed it. Give it a bit of a tweak, make sure it's good and tight. Okay, and we're going to do the same the other end. Let's get that out of my way. Once again, just going to pop that into place. Sometimes you have to kind of walk these on by giving it a twist. Line it up, and then we're going to take our screw once again, pop that in with a little bit of Loctite. Pop that on there, and then we are going to screw that in. So obviously I've tested it before I've put these on, mainly for the fact that if I don't and it's not screwed down, it dances all over the place. So pretty much that's our motor on. Give it a quick spin, make sure it's not going to foul anything. So these, when they're spinning, are what are actually going to give you your vibration. As you can possibly see, the gap between the screws and the actual weight are quite small. So it is quite fiddly to make sure we get it on correct. So that's our motor in effect assembled. The only thing we need to do now is we need to put some covers on it. That does two things. It stops you putting your fingers in it if for some reason you went in there with it turned on. And secondly, it stops any wires or anything else getting trapped. So what I've done is I have injection molded some end caps. So depending upon which batch you get, I do these in different colours. So these are a natty purple. The alien ones I did with green. There's some yellow ones out there. The latest batch I've done are now red. So these are going to fit on the ends. And once again, the screw in place. What I didn't do when I made the injection moulding tool was to actually put the two holes in. It makes the mould a bit more tricky to make for a start. Makes assembly, disassembly, kind of, I can't use these on different models. So some of the models only have one screw in the top. So I've not actually done that. So what I need to do next is to drill those, fit them in place, and that's in effect our motor done. Right, so what I have made is just a little perspex guide to allow me to drill my holes in the right place. So this is going to be a case of finding the right size drill, which is normally the one at the end. Nope, too big. A little bit in size. There we go. So we're going to drill that through there using a drill. So quickly pop that into there. Oops. Thank you, Ghostbusters. It is 12 o'clock. Okay, pop that onto there, line it up, drill 2 holes through. No real mystery to what we're doing here. Okay, so I'm just going to hold that in place and then drill that through. Especially if my drill wasn't bloody. Okay, so now we've done that, pop that onto there and we can screw it in place. And I've done that one a bit on skew typically, and the same with this one. So once again, pop that on there, drill that through as per what it was. Call that one a reject, and we'll do another one. Thankfully I've got plenty of spares of these. Okay, so here's what I didn't drill earlier. We will quickly drill that through again, making sure that we have it lined up correctly. Just readjust that a bit and give it another drill through that one. Right, so that done. It's just a case now of screwing these into place, and then our motor is complete. We'll just tighten that down. Oops. They don't need to be crazily tight. These are actually made out of low density polyethylene, so they're quite flexible, but that means as you screw them down they compress slightly. That actually stops them coming undone, which was more by accident than design. Certainly saves on having to put things like star washers or whatever underneath them, which would be another way of holding it in place. So that's pretty much our part done. Once I can get that screw in. Oops, that's not having it. Okay, let's tighten. So there is our motor, all complete, all ready to put into the machine. So if you made it to the end, congratulations. I know it's not the most interesting of videos, but I just wanted to kind of show what goes into making these. It's not just a case of buying the components, there is quite a time involved in actually assembling them as well. If I'm doing a batch of 50, that's going to take me 2 or 3 weeks to put together. Although I don't necessarily charge for the time, it is something to take into account that there is a little bit of care gone into putting it together, I'll certainly not slap them together with any kind of speed. I do try and quality control it as I go along. As I say, pretty much these are the last motors I've got. 10-15 more kits, and then I'm done. So I'm not doing this to try and sell kits or anything like that. They pretty much sell themselves. By all means, carry on buying the Stern ones. These are probably half the price. I think these are actually better. I've got these in all of my machines. And I know most people throughout the UK also have them installed. Installation, dead simple. Pretty much pop it in, screw it down, connect the connector to the node board, and you're done. I mean, it's literally a 2-minute installation. I'm not going to go into doing that. I don't have a handheld camera. So that's pretty much it.